We're giving cosine A is equal to 2/3, sine B is equal 1/3, and we were asked to show that cosine 2A plus B is equal to this value. The formulas that you should be familiar with, and they are in the formula booklet. Cosine sum and difference of two angles, sine 2 theta, which is double angle identity for sine as well as cosine, and also the basic right angle trigonometry, which I'm going to explain in here. We have a couple of expressions that I assume you already heard of. The expression sa katoa, sa katoa, sa sine theta equals opposite over hypotenuse, ka cosine theta is equal adjacent over hypotenuse, and tau tan theta is equal opposite over adjacent. So if I have this right angle and this is my theta, then this side is the opposite, this side is the adjacent, and this side is the longest one, the hypotenuse. So if you can look at theta, the side facing theta is the opposite, the side adjacent to theta is the adjacent, and the side facing the 90 degrees is the hypotenuse. Now let's take a look at the given and what can we establish from here. If I were to say this is my right angle triangle, if this is angle A, then cosine A equals adjacent over hypotenuse, so that will be my 2, this will be 3. Using Pythagoras, I can establish this is square root of 9 minus 4, which is square root of 5. Likewise, we were given sine B equal 1/3. If this is B, sine sa opposite over hypotenuse, so that should be my opposite side, that is the hypotenuse. Therefore I can establish using Pythagoras that this is equal square root of 8. What else we can conclude from here? From these two right angle triangles, right away I can establish the following equations. Sine A is equal root 5 over 3. Cosine A, it was given to be 2 over 3. Sine B was given to be 1/3. Cosine B is equal root 8 over 3. Double angle identities. I need sine. I'll come back to it. Let's go and apply the left hand side, expand the left hand side, cosine 2A plus B using double angle identity, which is this one, the first one. The middle sign switches. If it is positive, it becomes negative, and if it is negative, it becomes positive. So that will equal cosine 2A cosine B, and the sign will switch to minus sine 2A sine B. So I need the value of sine 2A from this triangle. Sine 2A is equal to sine A cosine A. Where did I get this from? From the second identity in here. Sine 2 theta is equal to sine theta cosine theta. So sine A is known. So that's equal to sine A is root 5 over 3 and cosine root 5 over 3 and cosine A is equal to third. That will render this 4 root 5 over 9. That is sine 2A. Also, I need cosine 2A. Cosine 2A from here, you are free to use this cosine square A minus sine square A, or 2 cosine square A minus 1, or 1 minus 2 sine square A. By the way, in here I made a mistake. That is sine 2B cosine A, cosine 2A, cosine B, sine 2A, sine B. No, that's correct. That is correct. Sorry. Okay, that is correct. Cosine, cosine, minus sine, sine. Alright. So now I want cosine 2A. Cosine 2A, I want to use it as cosine squared A minus sine squared A. And that is equal, cosine is 2/3 squared minus sine, which is root 5 over 3 squared. So what do we get? 4 over 9 minus 5 over 9, which is equal minus 1 over 9. Cosine 2A. So that is known. Now I go and substitute cosine 2A. I already found it to be minus 1 over 9. Cosine B from the triangle in here, cosine B is root 8 over 3 minus sine 2A. We established sine 2A to be 4 root 5 over 9 times sine B. From here it is 1/3. Work that out. That will be minus root 8 over 27 minus 4 root 5 over 27. Root 8 I can simplify it as minus 2 root 2 over 27 minus 4 root 5 over 27. That is cosine 2A plus B, and that is what we were asked to show. 2 root 2 over minus 2 root 2 over 27 minus 4 root 5 over 27. So therefore we can say we have shown that, or just simply QED. That is for the question. That's the only part that it has. The second question also identities. We need to know the cosine rule or cosine law, and we need to know the general formula for the area of a given triangle. That is the general one. The one that you're familiar with, areas equal half base times height, is a special case. This is a special case when the angle between the two sides is 90 degrees. Sine 90 is 1. That's why we see this form. So I'm going to use the general formula for this question. They gave me a triangle that has two sides. Let's call this is A, which is 4 centimeters, and this is B, which is 5 centimeters, and this is the angle in between, theta. And they are telling me the area is given to be 5 root 15 over 2 centimeters square. Show that sine theta is equal root 15 over 4. I'm going to use the equation. A is equal half A B sine theta. Meaning if I have two sides of a triangle and the angle in between, I can find the area. The area is given to be 5 root 15 over 2 equal half times A is 4, B is 5 times sine theta. And I want to solve for sine theta. You can see this. The 2 is in the denominator on the right hand side and the 2 on the denominator in the left hand side, I can simplify that. Likewise, so this is 1 and this is 1. 5 on the left hand side, 1 with this 5 is 1. So I am left with, after simplification, left hand side is root 15 equals 4 sine theta. Divide by 4, divide by 4, so sine theta is equal root 15 over 4 QED. So we have shown that. That's done. Next, find the two possible values for the length of the third side. If we call the third side x, by the way, you should be familiar that the third side should be greater than the difference of the two sides, which is 5 minus 4, greater than 1, and should be less than the sum, less than 9. But we're not going to utilize this right now. We are going to use the cosine law. The cosine law says a third side squared is equal, these two sides squared, minus 2 times the first times the second times cosine the angle. We are given sine theta. Sine theta to be root 15 over 4. I want to find what is cosine theta. Well, I can use the identity cosine squared theta plus sine squared theta is equal 1. Substituting instead of sine, that will be cosine squared theta plus, if I square root 15 over 4, that will give me 15 over 16 equals 1. Move 15 over 16 to the other side and simplify, that will be cosine squared theta is equal 1 over 16. Take square root, don't forget the plus or minus. That will give me cosine theta equal plus or minus 1 over 4. So now I go to the cosine law. X squared is equal 4 squared plus 5 squared minus 2 times 4 times 5 times cosine theta, which is 1 time is going to be 1/4, or I'm going to use the other value, 4 squared plus 5 squared minus 2 times 4 times 5 times minus 1/4, and find the value of x for each one. In the first equation, I get x squared equal 41 minus 10, which is equal 31. So x is equal to square root of 31. That is one possible. Length is square root of 31 between 1 and 9. Yes, it is. The second equation, x squared is equal 41 plus minus times minus plus 10, which is equal to x square root of 51. This is the other value of the third side, either root 31 or root 51.